All right, hello everybody. It's Alex again, and this is lesson 2 of chapter 1 for the E&M curriculum. Once again, disclaimer, this is not a replacement. This is just me going over my thoughts on what I find important and what I needed clarification on. Okay, so the topic of today is going to be the shell theorems. So I actually kind of forgot the shell theorems because it kind of becomes common sense as you go through this course. But let's jump right into it. So the first shell theory, I just realized that I wrote theorems. It should be theory. All right. So shell theory 1, it's basically a charged particle has all its charge distributed to its surface, and this is conducting. And acts as a single particle. Now, what do I mean by that? Okay, so say that you have this point charge, right? This tiny point, it's just a point in space. It has no volume, it has nothing like that, okay? But it has theoretically a charge, okay? A plus charge. And you have another point right here, and it's a minus. And from the last lesson, we know that they're going to attract each other, right? So, force vector that way and force vector that way. Okay. Now, the case is that everything has mass, some kind of dimension. Light gets a little iffy, but that's a very later topic. We need a shell theorem because what if the particle is, and I've been drawing particles like this, right? So these two particles right here have the same magnitude of charge. Would it act any different? The answer is no. It would act as if, that's kind of an inaccurate representation because I drew it much bigger, but they're going to have the same force. And technically, the force would also be coming from the center of this. So that's where you're going to start the radius, okay? So, or not the radius, well, you can call it the radius, but the distance between these two particles, right? So the distance between these two particles, the thing that's going to go in the denominator, of your Coulomb's law is going to be this right here. And that's it. That's shell theory 1. Now, shell theory 2, this is just something, these are just things that you should just memorize, honestly, until you get comfortable enough to and do enough practice problems that this is just the case. Inside a charged particle, inside a charged shell, conductive. And I'll explain that later when we get into Gauss's no net force. So say we're here and we have this guy right here. There's no net force in here. Okay. And notice that I drew two forces here. So if we know that shell theory 1 is true and all the charge is distributed across the surface so that it can act like a particle, right? Then that means that we have an infinite number of particles, right, with a certain charge right here, and we'll call it this one will be a positive charge. The net of these guys going outwards, right? Because you can have a force going this way and then a force going this way, and we'll talk about that later, electric fields and stuff. But on the inside, there's gonna be a net of 0, right? Because each one of these particles is radiating a force out, right? If that makes sense. Just the net force inside of these guys is 0. And that's it for this video.